Hey guys, welcome back to Absolutely Math, and in this video we're going to be discussing the geometric sequence. You're going to learn about the geometric sequence. Here we have a sequence. 2, 4, 8, 16, and 32 are the terms of the sequence, and specifically this is a finite sequence because it doesn't go on forever. So we have the first term 2 and the last term 32. Now, I'm going to introduce once again just basically what a sequence is. Well, the basics of a sequence. Right here we have a sequence. So a sequence is a list of numbers. 3, 5, 7, 9, 11. These numbers are called the terms of a sequence. And here again we have a finite sequence. This would possibly be an infinite sequence if it goes on forever, which is indicated by an ellipsis. If we have 3 dots at the end, which would mean it's going on forever. And we study sequences because they have patterns. Patterns where? Well, the patterns in the relationships between these terms here. Specifically, it's how these terms are related. That pattern is how these terms are related. So how is 3 related to 5? Well, 2 separates them. 5 minus 3 is 2. 7 and 5, what relates them? 2. Why? Well, because when we go from one term to another, we're adding 2. So 2, an addition of 2, is what relates these terms. This would be an ascending order. This is a sequence in ascending order. We could also have a sequence in descending order. So 3, instead of plus 2, we could go minus 2 is 1. 1 minus 2 is negative 1. Negative 1 minus 2 is negative 3. Until our last term. This is how arithmetic sequences work. You either add or subtract to relate these terms and go from one term to another or create a pattern. With geometric sequences, there's a pattern as well, but it's not by adding and subtracting. So for this sequence over here, try to find that pattern. Again, quick hint, this is a geometric sequence. So the pattern is not by adding or subtracting. You don't go from one term to another and define this sequence by adding or subtracting. So try to find out what that pattern is. Well, hopefully you said it's by multiplying. Specifically, multiplying by 2 to get from one term to another. For instance, the first term to the second term, 4. We'd go from 2 times 2 is 4. To go from the second term, 4, to the third term, which is 8, we multiply by 2 again. To go from 8 to 16, we multiply by 2 again. How about this sequence? Try to find that pattern as well. Again, it's a geometric sequence. The pattern is not by adding or subtracting. Well, hopefully you said it's by dividing. Dividing by 3. To go from 81 to 27, we divide by 3. 27 to 9, we divide by 3. From 9 to 3, we could also divide by 3. So now let's summarize or generalize. So we have this random geometric sequence, and each term is denoted by U1, U2, U3. So U1 is the first term, U2 second, U3 third, all the way up to the nth term, UN, whatever the number n is. This is a random geometric sequence, and we can generalize by saying that the pattern is, we can create a pattern in a geometric sequence by multiplying or dividing. So to get from one term to another, we multiply or divide. So again, if you've seen my previous video, you should know that in an arithmetic sequence, this number that we continually add or subtract to get from one term to another is known as the common difference. It's a difference common to all the terms. And in geometric sequences, we have the same thing, the same sort of, we have a pattern, but it's instead called the common ratio. So this number 2 that we're continually multiplying is called the common ratio, and it's denoted by R. The variable obviously doesn't matter, but it's traditionally denoted by R. Why is it called the common ratio? I'm going to explain that now. Let's have a look at that sequence, geometric sequence that we saw. 2, 4, 8, 16, 32. A finite geometric sequence. So we now understand what the pattern is in a geometric sequence. It occurs either by multiplying or by dividing. And in this sequence we have here, we're multiplying each time by 2. So that's the pattern, and that's how we get from one term to another. And we call that a common ratio, r. So r is equal to 2. 2 is the number we continually multiply. Why is it called a common ratio? Well, from the name common, it's a ratio common to all terms. Let's take the second term here. We have this second term here, u2, and we have the first term, u1, yeah, which is 2, and second term is 4. A ratio is represented as follows, like a fraction, right? We know what ratios are. What's the ratio of 4 to 2? Well, that's equal to 2. So this ratio of the second term to the first term is 2. Let's take any two terms again. The third term and the fourth term. Let's find that ratio. So u4 to u3, fourth term to third term, is equal to 16 to 8, which is equal to 2. See? The same ratio. We get 2 again. That's why it's called the common ratio. And it's the number that we always multiply by to get from one term to another. Sorry for this mess, but you get the point. All right. Thank you for watching, everyone. This is part 1 of geometric sequences. Come back for the next part as we dig deeper into this topic of sequences and series. Subscribe if you'd like to, and find my email down below. Send me any questions about math that you have. Goodbye.